Hello everybody, this is Ted Goth here with Michigan CNC Webinar. We'd like to thank you for joining us tonight. Tonight we have the special guest of Jay Johnson. He is the owner of J Tech Laser in Houston, Texas, and I first ran into him at the Vectric user group out in Chicago, and had a nice presentation and learned a lot about his lasers. I had seen him around on other people's machines, and I thought it was something that I might be interested in, so I thought, well, maybe others would be interested in it too. So I was pretty intrigued with it, bought one, installed it on my machine, and I'm pretty happy with it. So I thought I'd ask Jay if he'd come on and tell us a little bit about his company and give us a presentation, and if we can get some questions answered about having a laser installed on your CNC. Just a little housekeeping. I'd like to tell everybody to please keep their microphone turned off until you would like to talk. If you would like to talk, just turn your microphone on and ask the question. If you don't have a microphone, we'll kind of keep an eye on the chat button, so you can type a question in there if you want. The other thing I want to remind people is that I try to record every one of these webinars, and now I'm posting them up on YouTube. You can go into YouTube and then do a search, Michigan CNC Webinars and Tips, and you'll find most of the recordings of past webinars that we've had, and if this one records, and I'm sure it will, by tomorrow or the following day I'll have it posted up on YouTube, and you'll be able to have it for reference. So if you've missed something that Jay's talking about, or you want to use it as a reference, so it's a good place to go, is look on YouTube. So that's it for housekeeping. I'd like to welcome Jay Johnson from J Tech Phontonics. I'm going to go ahead and pass the presenting role over to Jay, and then we'll be able to see his screen, and then he'll be able to talk. If your screen, when his screen pops up on your computer, if it's not large, try to use your maximize window and maximize it out so it fills your screen in your computer. Welcome, Jay.
Yeah, thank you, Ted. I appreciate the intro. Yeah, like Ted said, I'm here to talk about upgrading your CNC machine with a laser. I guess I'm fine with anybody asking questions along the whole way. So if you have something that I'm on covering, then just feel free to speak up. And then there's plenty of time at the end for more questions as well. I guess, do most of the people here, were most of the people at the Vectric user group? Do we know?
I think we had 5 from here that were at the user group. Okay,
so I'll try not to use those slides as much. But
tonight so far we have 3 of us that were.
Okay.
I think Don was there and Rich was there.
Okay.
They're in the room. I don't know if anybody else was present.
Okay. Well, then I'll just kind of go through the website as well, and I'm going to have a couple slides from the user group to start off with. But we're a small company for people who don't know. We started about I don't know, like about 7 years ago or so, with just an idea of we actually got a 3D printer, and I saw an X, Y, and Z stage, and I thought, man, this needs a laser. So the first thing I did was put a laser on it, and we slowly moved into doing CNC machines, and we've been growing ever since. So it's been kind of a wild ride here. You know, we have a lot of customers. These are just a small part of our customer list. We have a lot of we have tons of enthusiast customers, but you know, there's a large range of research institutes and government facilities and such that have also. How do you go down on this?
Just scroll, just like
okay, yeah. All right, so we have, Intel, GE, and there's tons of industrial customers, but most of the people who buy from us really are just small shops doing small production or just hobbyist kind of stuff in their garage. And so this is what most people's shops look like, and one of the things that is a big deal is that there's not much space. So having a ability to put a laser on a CNC machine really kind of allows you to, one, save some money, and two, save some space. So I'm going to go through a little bit what a laser is. So these lasers are semiconductor lasers. When most people hear laser, they hear CO2 laser, and I think high power cutting lasers. These lasers are really not necessarily for hardcore cutting. They're mostly for engraving. You can kind of see why, because they're really small. So we can get the little laser head to be pretty darn small, so you can put it onto your machine pretty easily because its footprint is pretty small. They don't need water cooling. There's no high voltage. There's no alignment. No moving parts. So it really just allows you to get it onto machines where you can't put a large tube laser head on a machine. So our kit usually kind of comes in a couple pieces. There's a little laser driver and a laser head, and then you get a goggles and a power supply. But it really, our whole idea is just to treat it almost like as an extra tool head. So it's just another thing in your arsenal that is like a marriage between the router and the laser. So the things that the laser is going to do good, the router probably can't, and the things that the router can do really good, like cutting, the laser possibly can't. So let's see, allow Rich to join. Yes. So I think, let's see. So I kind of talked about why you would want to upgrade your CNC machine. You already have an XYZ table, saves time. And then you can also do these cool hybrid projects. So, it just adds new dimensions to your thing. So if you wanted to do something like that's a little bit more interesting, like if you wanted to carve and then also instead of painting, you can do some lettering or something like that, the laser is a really good option for it. These lasers are really, really good at engraving. They do a really good job of engraving in wood, and the speed of it is up to par with some of the higher power lasers that have to put the power down to go fast. So cool little things we have in the last year is we have a little bit more power, and we also have these little magnet ones, so you can clip them on and off with magnets so that you don't have to keep the laser on your machine all the time. And it also has a little shroud in the front to make it a little bit safer. So that's kind of a cool deal that we have now. So, what can you do? Like I said, it's mostly engraving. And then there's cutting of small things like, fabrics and papers and cardboards and such like that. Small, thin veneers, that's kind of stuff that really gives it so that your router, like a router would chip out a lot of times if you're cutting really thin veneer wood, but this really does a really good job of doing some detailed things. Plus, you can do a lot of detail work in lettering. I'll go through this on the website too, a little bit of more of the machines we have, but we do upgrade quite a few machines. And I'll hit that a little bit more on the website here. And there's a lot of examples on the website too. Some of the things you can do, a lot of people use it for like doing cutting boards and things. You can also, if you have a Spire, you can do 3D terrain maps. For the people who were at the user group, Ed did a really neat presentation of using the laser to make these 3D topographical maps. Other people have done it, to put rivers and roads and stuff on things. You can do some cuttings, like that's a veneer. Those cut on the top are skis cut with a veneer, thin veneer. Wagner skis uses ours to do that. And it can cut. It's just really slow. It does a lot of plastics and things like that. Foam is really kind of cool. You can cut really well with foam. And then, some things that we can do is leathers and some metals, aluminum, anodized aluminum. It can do pretty good. A lot of people use this at companies for aluminum. We also can do carbon fiber, some mirrors, like polyimide circuit boards and regular circuit boards. There's kind of a cool things. One of the things like a lot of people like to do is the pictures. So pictures on wood are really kind of a neat thing. There's a lot of people who sell these at markets and stuff and do pretty well at doing pictures. It adds a little personalization to what you're selling. And then really the cool thing is we do two things at once where you can cut and then you can also then go over it with a laser. I think that's one of the highlights of this. And I'll show a little bit of a project from last year that we did that kind of shows it a little bit more. This year was the chessboard project, you know, and we have files for this and Vectric has files for this, but I'll go through it really quick. It's kind of like a, it goes through how to kind of put it together here, but you can read the tutorial on how to do it. We won't go through the whole thing here, but you can basically set your tools up, and then you do your carving first, and then immediately afterwards you're lasering on top of it. So that's kind of a cool thing where it's on the same machine and you're engraving and lasering on the same machine without picking up your wood at all. It's kind of just a neat idea where you don't have to take this off one machine and go take it to a separate laser machine. You can just do it all in one spot. So that's kind of a quick rundown on that.
Mostly, we're not shooting them when I have a chance.
So I think you can't get control of this very easily. What's going on here? Oh, someone needs allow to come in. Okay. So if we're looking on the website, you can also see a bunch of, I'm trying to just scroll up here. If I do that, all these little bubbles go to the, okay, I'll just put those guys to the other side. Okay. So now I can scroll. Okay, now I can scroll. Okay. So if you look on the web, we have quite a few instructions on how to upgrade a lot of different machines. From like machines from Millwright, Robotics, the XCarve, Ultimakers, you know, Shapeokos, Shopbots, Axiom. Some of the people have their own upgrades that we sell. Axiom has their own version of ours that we sell to them, and then they distribute, and we kind of work as a team on. And that's specific for the Axiom machine. That's kind of a cool deal. That has it's all plug and play for Axiom. There's other ones that we sell too. Of course, I can't get back to my own website now. We sell to Millwright and a couple others that they can buy direct from them. So it's really kind of neat that way. And then if you click on any of the upgrade instructions here, you can see, let's say if you had like a, I don't know, a Mach 3 machine, you can go through and you can see specifically what you need to do for Mach 3. So all the instructions are pretty easy here and on the website on how to hook it up. That shows you how to do the profile and everything for Mach 3 and what the settings need to be. Some of the other ones are a little bit more in for the machine, like the Shapeoko 3 kind of has a little bit more instructions, and we also have mounting kits and stuff available for it, so you can go through and see how to put the whole thing together. And it's really not that hard. It takes about an hour or two. I mean, Ted, how long do you think it took to put yours on?
Yeah, I would say an hour.
Yeah, yeah, not too long. I mean,
if I wanted to make it a little nicer, all I did is took two pieces of wood and made a mount. And then when I purchased the unit from you, I purchased the removable one. So I just screwed it onto a piece of wood. Yeah.
Yeah. And if you don't have your mount, like we do sell a lot of mounts. So we have two kinds. We have the standard laser heads, and we have this magnetic upgrade, the little shroud upgrade for it. And so we have quite a bunch of different mounts and stuff like that. We have a bunch of mounting kits, and we have some of them in the magnetic. And if you don't have a mount or if the machine's not listed on here for a specific mount, we're always designing ones and doing it on the side as well. But and we can help you mount your own. But then we also have this little magnetic base plate that you can just put onto your machine. Just find a place for it, and it has the magnets in it, so that you can use the magnet version of the shroud, so you're a little bit more protected. So it's pretty neat to upgrade. There's a lot of different instructions on how to do it. And there's specific stuff on the blog too. Like if you want to know exactly how quick it is to engrave on acrylic or something like that, then we have we have a lot of blog posts, and we have them in the applications area here. Here's some people who do more images engravings. Like if you click on, I think if you click on some of this stuff, like you can go and find out just how quick it is to cut acrylic. So this was using a 2.8 watt kit. Any of the lasers that you find, anything on the website in terms of speeds and such, you can just scale it for power. So if it says that we did it at around 1.8 watts, then if you're going to buy the 7 watt laser, it's just going to be that much faster. You know, so it's proportional pretty much in terms of the speeds and stuff. But you can go through and see, and there's a lot of in-depth information on that for some of the applications, depending on which ones we need to do. Let's see. Why doesn't it go? Oh, because people are asking to join. Okay. So more people are joining. Welcome. Yeah, so if you go through, there's a lot of different stuff on the site here in terms of how to do some different things. Like if you wanted to learn how to do anodizing engraving for aluminum, there's it here. A lot of times with metals, like you can't really engrave directly on metals, but you can certainly take off anodizations. Like in this case, it's a red anodization. So you can see that this one did it in one pass at around 4,000 millimeters per minute, which is not too bad. That's pretty fast. This one, we had to slow it down because our machine was just bouncing a little bit too much. But these guys, Precision Mounts, use it for serializing their stuff. And you can see here, it was going so fast that, you know, it just, our machine wasn't tight at the time when we were doing that one. So it kind of did it in different speeds. But yeah, and if you go over to the blog, there's quite a bit of info on how to set things up and things. We sometimes do little projects or little things. And we have something here. If you want to get one of the higher power lasers, we kind of talk about our lenses options. There's a high resolution lens option in a high efficiency. And you can see that the high resolution will make that spot size just a little bit smaller. These are diode lasers, so that means that they're going to be multi-mode, which also means that it's going to be a rectangle. So most people think laser, and they think that laser is going to be this teeny little beam. And in a lot of cases, it is. If you're using a CO2 laser, it's going to be a Gaussian profile. But in these diode lasers, it's going to be a rectangle. So it's very important to get it pretty high focused. And if you want to do anything that's going to be super teeny, then high resolution is the way to go on the higher power ones. And you can kind of see that the spot is going to get from a rectangle, it's going to go into more of a circle. And then you can get down to, you know, about 6-point fonts, depending on your speed and power level. And sometimes the high resolution lens helps with cutting too. On foams, it's going to burn a little bit more with that larger beam. So this is that foam from Home Depot, the pink stuff that's used as insulation, and you can cut pretty decent on that at a decent speed. So
is that one pass or several passes?
That's one pass.
One pass. Okay.
Yeah, that's one pass. And this is actually like going pretty fast too. So this is one pass at a 3.8 watt laser at 2,500 millimeters per minute. So I think that's like that's like almost 100 inches per minute or something. I'm so bad at converting things. Like let's see, 25. I think that's 100 inches per minute because it's 25.4, right? So yeah, 98. So that's pretty close. I mean, 100 inches per minute is not too slow. And it got
a little bit. 3.8 laser. So if you had a 7 watt laser,
yeah, it would go at the same speed. It probably would go about to there. It almost would cut all the way through at 100 inches per minute. If you slowed it down to about 50 inches per minute with a 7 watt and the high res lens, you might get all the way through. The other problem is focusing. So the depth of focus on these lasers is going to be about 1/4 of an inch. And we have a little blog on focusing here. Let's see. And let's see, cutting plastic, anodized aluminum. So this is our little focusing blog. And it shows what these beams are really doing. And so the lenses are going to be an imaging lens. And what it's going to look like is this. So it's going to come from a diverging beam, into a point and then diverge again. So what you're really looking for is this hourglass kind of a thing. And so if that point only exists in about a 1/16 of an inch, then if you're cutting something that's, let's say, an inch deep, you're going to probably want to do multiple passes anyway, and go and move the laser down a little bit as it's cutting through, just because the focus point is a little bit smaller. So, but and then for people who haven't seen the Vectric stuff, I think most people here probably use Vectric. There's a lot of software options depending on which machine you have. Like a lot of the GRBL machines use a lot of different programs, but most of them use can use this Vectric one. So we have a plugin for a post processor for Vectric, and we're working with the new 9.5, and we're working with the team over there to get even better post processors that are going to be using the actual laser tools. In 9.5, because in 9.5 you can go in your tool database, and instead of using an end mill, you can put a laser tool in. But all the post processors need to change, so we're working on doing that. But you can basically go and download for all these different machines a post processor. So if you have a Stepcraft or a CNC Shark or a 3D printer or WinPC or Linux CNC or Axiom or all these different Mach 3, then all these post processors will work. And you basically can just use it as a tool, go through and do your choose your vectors and go set your tools and output your tool path. So one of the projects we did last year was this little idea of this what's it called, a Aztec calendar, doing a hybrid version of Aztec calendar. And let's see if it's going to go there. And but it's kind of cool because this one followed the contours pretty well to get the final output there. So instead of, you can basically, this looks like you have a 300 watt CO2 laser that cut into this. Instead, we used a V-carve and our laser, and it was our $1,000 CNC machine with our $300 laser on it, and turned out to be looking like we had some sort of really awesome kind of machine with it. And that's one of the neat things you can do. So this one kind of goes through how to set up your tools and for the carving, and then also for the lasering. It's not too hard. You can walk through the tools and stuff like that, how to do it. And the big part about it is setting your offsets. So we set our offset and then just kind of run the same file we did for the carving. We just did a different post processor on it. So we're not going to do a carve post processor. We're doing the laser post processor. So, and it turned out pretty cool. But I guess I would open it up. Does anybody have any questions that do specific stuff you guys want answered?
Remember to turn your microphone on if you want to ask a question.
I know you said you're limited to what you can cut. Can you cut like balsa wood and stuff like that?
Yeah. So anything that's going to be like non-dense, it can cut. So like a lot of non-dense balsa, non-dense wood is obviously balsa and basswood. They can cut pretty good. Let me see. We did it a long time ago. Let's see. We did it a bunch. We did it really long time ago. Let's see. This is back when our lasers were not even, so like you can cut some foam boards and stuff like that. So we did balsa wood. It looks like we tried that in 2013. So our lasers were really, really low power back then. I probably should revisit this. But yeah, you can cut balsa wood. It says this one, so we were using, what was the power we were using? This was a 1 watt laser. So we were doing 1/8 balsa at 150 millimeters per minute with 3 passes. So that's at 1 watt. So this would be 1 pass with like the 7 watt. It's going to be 1 pass at about 400 millimeters per minute. So that's like 15 inches per minute. So not super fast, but you can do it in 1 pass. Balsa wood is one of those that you can actually cut pretty decent. You start thinking about the physics of it. Is anything that has like it's just non-dense. It doesn't have like a lot of, if it does have a lot of air into it, then you can cut it pretty easy.
You're talking about 1/8 balsa?
Yeah. Yeah. Yeah, it cuts through 8-inch balsa fine. obviously the thinner you go, then the easier it is to cut. So
when you're setting the power on your lasers, you're using the RPM for the power? And when you do that and you say that you want it at 40%, and say you got a 7-watt laser, is that 40% of 7 watts? Is that what it is, or?
Kinda. So it's going to have a peak power. So when you have the 7 watts, you have this driver, and so this driver is going to be providing the current to it. And there's a whole bunch of stuff on this driver here. And here's kind of what the pulse would look like. So this is what the driver is outputting to the laser head itself. And so what it's going to be is pulse width modulated. So if you say in that RPM that you wanted 40%, it's normally set up depending on how you set it up. Like in your system, Ted, I think we set it at 1,000 or something like that was our number. So 40% would be 400. Or did we set it? I don't know if we set it up at 100 or not. But so if you just do that number for your RPM value, it's going to output a wave that's, in this case, this is 50% power. So you're going to see it's going to be at the 7 watts for 50% of the time. So it's off for half of it and on for the other half. So max power, peak power is going to be 7 watts, but the average power to it is going to be more like about, 50%. So it's going to be about 3.5 watts. And that's one way to do it. You can also turn down the laser driver to be half power as well, and it just goes 100% at 3.5 watts. And this really works out different for different materials. Sometimes it's better to do this reduced duction power to have the high peak power, and then it burns something off, and then it gives it a rest for a little bit, and then it does another blast on it. A lot of times that works really well for plastics, for engraving on plastics, especially thin plastics that you want to cut, because it takes a little while for it to get going, but you don't want it to catch fire or burn really, so it turns it off for a little bit of a time. So a lot of times if you adjust the RPM value, you're going to have a decent job on doing it. We have a question from the chat group, so let's see. Bought a Shark CNC about 6 months ago. I bought the laser attachment. What wattage is this laser, and where can I find the correct settings to use the VCarve Pro? So a Shark HD CNC 6 months ago. Well, it depends on which. You bought the laser attachment. No, you bought the laser attachment that they sell. So Shark also has a little laser that they sell. We sell a laser for Shark. So whoever's asking about the Shark, we sell any of our kits, and we have a Shark upgrade instruction. Let's see. The Shark HD is CNC Shark. CNC Shark. Yeah, second one. Yeah. So I think that their laser that they have that they sell is about like a 1.8 or something. I don't think it's more than 2 watts. So it's going to be a pretty low wattage laser, I think. But you need to check with them next wave on the lasers that they sell. If you bought ours, then I can tell you this is the page on how to hook it up and stuff. But it's basically it's just our laser, so it would be the power would be listed on it based on which one you bought. So, yeah. So I think there, you can look in the Vectric thing, and it goes a little bit more on how to set it up. I can talk about that a little bit. So the tool die, if you set it up as an end mill, which is the old way of doing it. So if you have any of the version 9 or earlier, and you can still do this in 9.5 too, and all of our post-processor work, the diameter is really the spot size. So that's the spot of your laser. And then the spindle speed will be, like Ted said, is going to be your percentage duty cycle if you set it up on a PWM machine. So a lot of the Mach 3 stuff you can set up being PWM, and that will vary your power based on duty cycle. And then obviously your feed rate is here. The feed rate, the faster you go, the lighter it's going to be. The slower you go, the darker it's going to be. So we tend to make a different tool in here for different types of woods and also different darknesses. So if you make a tool that says dark, you're going to make that feed rate be a lot less. and if medium is going to be somewhere in the medium, and then light will be really fast. Like for the 7-watt laser, it's going to be on wood. I think it's going to be somewhere around, if you're in inches, it's going to be like 120 inches per minute for decent engraving. Like it's going to be somewhat light, but not too light. A medium would be like somewhere around 90, and then a really dark would be somewhere around 70. And then you just put those different feed rates in as your tool, and you have different. You can go in Vectric and make your vectors and make them different colors. And that's kind of what we did with this chessboard here. We set up a different tool on the little squares there to have the lighter portion be going faster and the darker portion be going slower. And that just optimizes your overall throughput. So if you're going to run if this file ran for like a half an hour and we just set it at the dark feed rate, and then just you can reduce the laser power as well for the lighter areas, but it's going to go the same speed as the low feed rate. So you add on, a few minutes, or, just because you're not optimizing your speed. So it's just a little bit nicer to optimize your speed to go and make the colors based on speed, but you can also use your laser power too. And that's definitely something you can do. So,
did you have to make 2 different files to get the darker and lighter areas? You have to run, like for all the light areas, you have to run one file and then run another file for the dark areas?
No, you have the light areas and the dark areas are on the same tool path. So we just use different tools. So you select a vector using that tool, and then we just had it. I believe it was the same tool path. Like then you just choose. I see if I can figure out where we did that. We have all the tool paths and stuff. So we have vectors for the laser and vectors for the carving. I believe we just had it. It was just 2 separate tools, and we just chose, because in Vectric and VCarve you're allowed to choose 2 tools for one tool path, right?
Right. So you just set up a second file, really. I mean, it's the same whole file as a group, but you're setting individual tool paths for certain jobs.
Yeah, I guess so. So I guess it did do the dark first, and then it did I'm trying to remember if that's how we did it. This was such a long time ago. This was last summer, and to tell you the truth, my intern did this project, so I'm trying to remember how he did it. I think somehow we managed to get that file to be all the same. It might have done the dark ones first and then just ran the light ones afterwards. I mean, you could do it either way. There were like a few. I think he separated it into different tool paths. So I think he engraved the medium squares, the letters and numbers, and then the outside line. So I think that we did it all, and then you'd engrave the filigree afterwards. So we just would finish one tool path and then run it.
Right. That's what I would think you would do is you'd laser all of the light area and be done with it, and then you'd run the second tool path, and all the dark areas would be run.
Yeah, and I think that's...
It doesn't actually just do the square and keep switching between light and dark in that same square.
Yeah, I don't think it does. I think you're right. In the Vectric world, that's exactly what I think we did. If you have a GRBL machine, like a Xcarve or a Shapeoko, then it would probably be doing it in the same tool path. It would just be doing it all in one, and it would have varied the laser power to get to get the difference, because it would be doing it more like an image instead of a vector a lot of times. So, but I think you're right. It's going to be separated into 2 tool paths. So.
Okay.
Yeah. Anybody have other questions? Uh-huh. Oh.
John, you're really broken up. We're having a hard time hearing you.
When you're doing plastics, can you do you have to leave the paper on, or can you take it off?
If you're going to be doing plastics, it's going to depend on whether or not it's see-through or not. So this is a visible wavelength laser, so anything your eyes can see through, it's going to go through as well. Like things like clear, you're going to need to leave the paper on because it's just going to go right through it otherwise. So I think it really depends. I usually like to engrave on plastics that are not clear, without the paper, just because the paper has a tendency to somewhat burn. But you can do, let me see, you can do, and we need to do a better blog post on this, but we've tried doing clear acrylic, and it does work pretty good as long as you leave the paper on. So this is kind of showing for one of our other lasers that you can actually engrave using the paper that's left on it. That's with an old laser. That's like a 2-watt laser, and unfortunately the picture that we started out with wasn't that good. I would have probably gotten a better image to get a little bit better clarity on it. But yeah, I mean, generally, I think that you would want to leave the paper off if you can. Like this, our laser shielding, like this was cut and engraved. So on our laser shielding, this was engraved with our lasers. That nice kind of frosted look. That's because we left the paper off. And this particular material is very absorptive to our wavelength, just because we make it and we specifically designed the plastic to be absorptive so that it acts as a barrier. But it does a decent job with plastics. You know, I would say to only do cast acrylics though. Any of the thermal plastics like Lexan or ABS, they're very toxic. And they also tend to, they're thermoplastics, and almost by the nature of the name, that they catch fire easily. So I'd stick away from doing them and just stick with the laserable plastics. And we've tried a lot of Romark examples, like the let's see where it is up here, like the multi layer plastics. Like this one up here, the Hello World here, where you can have the top of it be black and then the white underneath it to do like letter panels. And they have a lot of cool ones that they make that almost look like they're metal. Like it's kind of like a shiny material, and then they have black underneath it. A lot of people use that for making panels and stuff for various instruments and such.
So you said that engraves really nice, huh?
Yeah, it does a decent job. Yeah, I mean, it's you know, anything that you're going to do on ours versus a CO2 is going to be a little bit slower, but it does a pretty good job. I mean, overall, I mean, we have a 100-watt CO2 machine, and it's not as big as our CNC machine, so we tend to use our lasers more than anything when we do projects. And it does a pretty good job. I'm impressed by how many different things that people come up with that you can do with these little lasers, you know, for these little cheap little add-on attachment lasers. If you just try it and you have a little bit of patience to figure it out, it works pretty good.
One last question.
Mm-hmm.
What's the longevity of the laser?
That's a good question. I think, you know, we have a range of lasers. So the lasers that we have, these 405 nanometer lasers, those are specific. I wouldn't recommend buying those unless you have a specific application that needs 405. And then you start getting into the 2.8 and the 4.2. Those are going to last for over 3,000 hours. I quote 3,000 hours just because in certain cases, if the environmental conditions are really bad, because we have some customers in like Singapore who run in a factory, and I swear their factory is 110 degrees and not air conditioned, and humidity is crazy. They run it all the time, all day. We really think that most of our lasers, like we have most of our 4.2s, they haven't come back, and we have shops running them on 3 shifts. And so I think, you know, it's definitely over 3,000 hours. The 7-watt is going to be a little bit less, just because it's the same diode as the 4.2. It's just heat sinks a little bit better. It has a little bit more, and then we just drive it more. We just drive it harder, but it's the same diode. Just it's going to be a little bit less lifetime. You can run this laser at lower powers, though, if you want, to get the same longevity. we've only had this one out for like about 5 months now, and Carolina Custom Foam is running 2 shifts with it, and I think they're already over 1,000 hours on their first one. So I know it at least lasts 1,000 hours. So.
How about warranty?
90 days. You know, if anything goes wrong with it, you know, we have a pretty decent policy with it. Even if your laser dies and you just haven't used it that much, just talk to us, and we're really good about either making sure we fix it or just give you another one. You know, we're in the business of making our customers happy. We're not the big guys, you know. We want to have people be happy with our products and want to tell their friends about it. So warranty is 90 days for anything, no matter what. And then after that, then you know, we help you out no matter. We'll try to help you out. I mean, if after 90 days you've already put like I don't know how many 90 days, if you ran it 24 hours a day, how many hours that is, but you know, depending on the situation, I don't think anybody does. You know, like if you didn't use it for 6 months, you say, hey Jay, I was trying to my laser and it just seemed to be broken after 6 months or whatever, and I didn't use it that much. Just call us and we take care of you. It's no big deal. So, but we really don't have many problems. You know, we've tried to weed out all the problems. You know, we test everything ahead of time. We have a pretty detailed QA process because we do send these all over the world, and we sell them to industry, so you kind of have to have them work. And I don't really like we don't have a huge department here for customer service, so we do things right the first time so that we don't have to figure out how to fix stuff in the field, is what we usually try to do. So most of our laser stuff is, you know, it's pretty rock solid, except for the occasional snafu that just happens during shipping or something like that. So.
How much do they cost?
Like a 16 balsa wood and 1/4-inch plastic. What would you recommend for a starting laser?
Well, I mean, if you want to do cutting, it's going to be the more power is the better. So, I mean, 7 watts is probably the way to go. And so if you're looking at a 7 watt, you're looking at around like, you know, it's around $625. We sometimes run promotions just to get a little bit off. And actually, if you go, I just did a coupon code for this group. If you type in Michigan CNC, you can get 5% off. You know, I think if you want to do any cutting, the 4.2 or the 7 watt is going to be the way to go, just because it has the most power. I mean, if you want to it just talks about your patience too. If you want to do cutting, it's going to be slow anyway. So if you're willing to wait for it, then the 4.2 or the 7 can do some decent cutting. The prices are all listed here. I think, you know, you're going to be in it for around $350 on the 2.8 or so. 4.2 gets up to more like 500, and the 7 watt gets up to the 600s, depending on what you get. If you have like one of these machines like the X-Carve or the Shapeoko, we have it all in one spot. So you can say, okay, well, I want the 7 watt. If you get everything loaded on the 7 watt, I think you want the dust boot mount. You want to get the shroud upgrade for $50. Power cords are power cords. And you also want to add the high resolution lens. You're talking about $725 for the highest power with all of the options on it. Magnetic, quick connect, and all that stuff. So.
Yeah, I think I had $715 in everything, but I'm not sure I got the high resolution lens.
I think you did. I think you might have. Yeah. Okay. Yeah, you had that.
$724. Yeah, I know it was just a bit over $700.
Yeah, for the top of the line, most power, biggest one is about $700. Then we have a bunch of accessories that you can buy. So I think, yeah, for yours, we bought you the. So if you have a big machine that's like that you need to do yourself, we have like laser and fan extension cables. So you can really just buy the main laser kit, and then you have to go through and see how far away your driver is from your gantry. So you can, I mean, some machines are big, so you can get up to 20 feet. So that gives you 23 feet of travel between your laser head and your driver. And so you can just buy the base kit and then buy this extension cord to get you all the way over to there. And it's not too much. We try not to. Our cables and stuff are not too expensive. I mean, $25. We try to keep it not super expensive. And then you can also get I forgot what other extensions you can get, but it depends. You just call me up or email me, and if you have a specific machine that is very custom, then I can help get you what you need to have it all work on your system and configured. So.
Okay, Jay, we have two questions in the chat room. One question is, what is the distance from the laser head to the focal point? And then the other question is from Gabriella. She has, I have a quick connect, and is it worth it?
Oh, she said it is worth it.
Oh, and it is worth it. Oh, okay, yeah, you're right. It is worth it. Okay.
Yeah. So that's a good question. I'm glad that she has the quick connect, and it's worth it. So it depends on what laser you have. If you just have the non-shrouded, it's going to be 3 inches on the non-shrouded for the 2.8 watt laser, and then 1.5 inches on the 7 and the 4.2 from the black heatsink down to the work surface. So you have to measure it from the base of the black heatsink. And so when you have it on your machine, it's going to be from the base of that little black heatsink, not the lens. That's going to be 1.5 inches on that particular case. When you get the shroud, we focus everything, since it's already in the little shroud. We put it together and we focus the laser so that it is basically, we don't have a picture of it there. It's 1/8 of an inch from the base of the shroud. So let's see if there's a picture of this one. So you're pretty much going to have it all the way down on the work surface. So yeah, here it is. So you're going to have it just touching the work surface, just about 1/8 of an inch above that. And that will allow you to not necessarily have to, I mean, I will say you're always supposed to wear goggles, but safety is always up to you and your shop and how you feel comfortable with. And in this case, you're pretty darn close to the work surface, and the shroud is big enough that if you're walking around there, you won't just, if you glance over there, it won't be this giant bright spot, because you can see it is a bright spot. That's without the shielding, and this one's with the shielding. So, but the focal distance is going to be about 1/8 of an inch from the bottom of the shroud.
Is that just orange acrylic plastic as a shroud?
No, you can't just go to any.
Special plastic.
Yeah, it's special plastic. Yeah, it's special plastic. I mean, if you get an orange acrylic plastic at the store, there's no guarantee that it will work. We buy our specific for the properties of the plastic, and then we used to have it specially made in Germany. Now it's been switched over to Mexico, but yeah, you can't guarantee that any just orange plastic anywhere is actually going to solve the problem. We test every piece with our equipment and make sure that it's doing what it needs to do in terms of the OD capabilities of it. So, and we try to keep it pretty cheap. I mean, if you go to any other place that has laser shielding like we do, they're charging like $200 for a 12x12 sheet, or $150. So we try to keep it. We don't make much money on the shielding pieces because we're trying to be the safe company. We have in our lasers, there's no one else selling these little toolkits. We're the ones who came up with the idea on how to do this. And so the FDA, we work with the FDA to make sure that we're doing everything we can to make it as safe as possible. Because, it is kind of the Wild West frontier with these lasers. I mean, most of the classifications for them were done in the 70s, and expecting no one to be selling it to the public. So, I mean, we have the key switch and the safety interlocks and the remote reset, or the reset switch where you're supposed to, in case the power comes off. So if you're using the laser and you will go away and the power turns off your machine, and you go away from your machine and you come back, your laser won't be turned on automatically. That's why we have that. It's annoying sometimes that you have that reset switch there, but it can save your house and your life. That if you walk away from it when the power's out, that it won't just turn back on. And a key switch is important. It's a small thing, but man, it's important to have a key in it so that no kids can get in and turn the thing on. So, but yep.
Yeah, have you considered putting that whole board in a in a case, in a box, so it's covered so it doesn't get full of dust.
Yeah,
Have
I've considered that. Yeah, I think.
Have the switches outside.
Yeah, we looked at having one machined.
The whole thing is a real neat package, but then the circuit board's all exposed.
Yeah, and one of the reasons why we have that is that it's because it gets really hot. So we had a design that was a machined aluminum design with some holes in it and a little system to keep the dust out and everything. And the cost of goods on the driver alone was going to be $450.
Okay, so just the cost down.
Yeah, it really comes down to the price point. We're trying to keep this as cheap as possible, so that people spend $500 and really, if you try to buy a 7-watt laser, that's more like a that's a previous companies that just sell optical stuff like Thor or Edmunds or Newport, and you buy a 7-watt laser from them, you're going to be spending about $5,000 or $4,000 on it. So we really are trying to keep this as cheap as possible so enthusiasts can use it. I understand, yeah, the dust gets into it, but they're pretty rugged. We've designed them to be pretty rugged, and we've seen some come back to us to get cleaned up after 2 years, and I usually just take a little bit of that canned air and blow it off, and it's fine.
Okay. A question that has been brought up tonight is engraving leather. Does that work out okay, and is there a problem with smell or fumes with leather?
I would say it works out. I wouldn't say that it's okay. I think it is definitely okay. I think let me see if I have some pictures. The smell, I was told, is horrible because it's literally burning a cow, right? So, I mean, in general, I think I would have a very, very well ventilated system if I was going to do leather. There's these people who do these really awesome. I'm just trying to figure out if I have a picture of it. This guy does these really, really cool leather wallets. Oh, here you go. I think this is it. And they're just super awesome. Where he does these like cartoon things on it and does a bunch of different kinds. So I mean, yeah. So leather works, and he does high end. This guy's doing high end European kind of boutique-y kind of stuff. I mean, he said he sells these wallets for about $500 each. So yeah.
With no money in them.
What's that?
With no money in them.
Yeah, no, yeah, exactly, yeah. The wallet doesn't come with $400 in the wallet or something, yeah. Yeah, you definitely can do leather. Leather's one that you can do, so.
Well, I'm extremely happy with my unit, and the one thing I really enjoy is the quick release. I have a table saw that's near my CNC, and when I use the table saw, I get dust in the room, and it fills the keyboard and all kinds of things. So I always, when I get done with it, I just take it off and I throw it in a little tiny camera bag, and then when I need it, I pull it out. It takes me 2 minutes to plug it in and get it up and running. Yeah,
that's cool. Nice. Yeah, I was showing a picture here too. These are the people who make the foam cases, and this is all done with our lasers. I mean, they cut the entire thing out with our lasers, which is kind of cool. So
now do they have to have multiple passes to cut that?
I don't know. I think he does
quite a bit of that foam, and I had bought some. I don't know if you're familiar with Cap, and they make a foam that it's called a Kaizen foam, and you pull it apart to put. You draw a shape on it, and you take a razor and you cut the shape out. Then you pull the foam apart to put your tools in a toolbox and stuff. And that's interesting. They must cut all the way through and then glue a bottom on it?
No, they actually get the power precise and the speed precise to do it down to the depth they want.
So are they pocketing that whole area?
Yeah.
So they're just evaporating that whole area?
Yeah.
Put that case back up.
Yeah, let me see. I just closed it. Let's see. I think it's here you go. Yeah. So this picture here, yeah, it's. I can get it back up again. Yeah, it's all pocketed, I believe. Customers example photos. Yeah, I think it's all just pocketed. I mean, he does some things like this where that's certainly just a design on it. But yeah, I think this one, I think he just pockets the whole thing. He says I think he figured out how to get some sort of foam that you could use a router on it too. But
that's real interesting to be able to do something like that. Most guys would cut that out, pull out the middle, and then put a bottom in it.
Yeah, that's all just one piece. He says he does it all just one piece.
Be very, very interesting. And that's all done with your lasers, eh?
Yeah, he buys a ton of them. Yeah, because his business is going good. So yeah, I think he's running. I think he's running 6 of our lasers now full time, all at once. So
interesting.
Yeah, yeah, they do a pretty good job.
I want
so. Sounds good.
One thing that you didn't mention, Jay, that I found out after I bought mine, I still would have done the same thing as I did originally, but I found it quite interesting, is that you not only sell the laser, but don't you sell a full machine?
Oh, we do. Yeah.
Yeah, talk to people about that, because I don't see that advertised anywhere. It's
we have so much stuff going on with just the laser side that we actually have a full machine, but we don't really advertise it that much. So people are finding it out anyway and buying it. But it's a full little desktop machine that has a little controller, a little ZRBL controller, has a Z stage and our laser on it. Could get the other one if you don't want to, but the one with the Z stage is nice. And what you do is you buy the rail system, and you can get up to 60 by 40 or up to 60 by 60. We kind of recommend only going up to 40 by 40 because that's still kind of super large. And then you buy our kit.
4 foot by 4 foot.
Yeah, you can get 6 foot by 6 foot, but yeah, you can get 4 foot by 4 foot. Yep. And it's just a rail system with our electronics on it. Yeah, it's just a neat little machine. And it's just kind of a do-it-yourself little machine. It's under, it's called the Acro by Open Builds, but we do all the electronics for it and all the laser stuff. So if you go up here to Open Builds Acro upgrade, you can kind of look and see how it all goes together. It takes a couple hours to put together, and that's it. And then you can do pictures with it. Has our own little controller. We made our own controller. You just have to put it together a little bit. It's not too hard. All the parts come with it. Has a little e-stop panel, pause and resume buttons. The little laser driver fits in right there. I mean, it's kind of a neat little machine. It doesn't cost too much. I think you can be all in with the laser for like around $1,100. So you have a full laser.
What interested me about the whole thing is for someone that was thinking about buying a Shapeoko or something like that, here you have your whole system all together as one for a lot less money.
Yeah, because you're not really worrying about the CNC part of it. If you just want a laser system that's going to be just XY rails and an easy to do laser, then this is a beginner, easy way to do it if you just don't mind putting together a machine for a couple hours. I mean, it's not too hard, but you end up with a neat little machine, and then we have the software for it to run it, and you can do pictures and vectors and everything with it. So it's kind of a neat little idea. I think if you get the and we have it in the new products. Let's see, under Acro and Laser Electronics bundle. So it's kind of hidden there. We're going to try to promote it a little bit more next year. We're going to be moving into a much larger shop, and we're hiring a couple more people to be able to put this stuff together. So I think that's going to be next year's thing, is to push this a little bit more. But yeah, without the rails, you're all in it for about $1,000, and I think the rails cost another $200-300 depending on the size. So.
Okay, well we're pushing an hour, so we're nearing the end.
Okay.
I just got a question for you, and if anybody else got one last question, then we'll take it. What's the future bring for your company? What do you see on the horizon, or what are you working on that you're willing to share?
I think we're always just looking for. We're waiting for more higher power diodes. I think that's the thing. Is really next year is going to be a lot more of the applications work. So we're going to be doing a lot more with finding the materials that work well with our lasers and actually putting them in the store so that you can have settings and things like that. You can make the projects work and without any trouble. I think this machine, we're going to start pushing it, but when it comes down to more powerful lasers, it's really, I wish we could do anything with it, but the diodes are really controlled by one company, and the patent doesn't expire until another 10 years. And even then, it's very hard to do. But, I think this is a neat little niche kind of market that we have here, and we're going to always try to be in the forefront. We are continually looking at higher power lasers that can fit, including fiber lasers. So that might be in the near future, hopefully, as fiber laser market gets a little bit smaller and a little bit cheaper. To be able to have a cutting laser on a CNC would be really cool, like a real cutting laser that can cut through 1/4 inch wood really fast. So that's kind of on the future too for us.
Do you think that's a possibility in the next year or 2 years?
Yeah, it's just the price is kind of not there. Right now the prototype that we have is going to cost us $4,500 to put together. And so we're looking at selling it maybe like, with labor and everything on it, to get the price that we need to run a business, it's going to be more like around $7,000 or so. And so really you're talking about if you have a $20,000 CNC machine, then you might be willing to spend $7,000 on a fiber laser head. I'm trying to get that to be pushed down to more like, 1,500, 2,000. And so I think it's going to take a little bit of time for the laser technology to come down to that level. If you look at the lasers that we're using right now, to have a 7-watt diode laser on a machine for about $700, just 10 years ago, that same thing, one, didn't exist, and the other technologies that went with it, that would cost you about $30,000. So if I'm hopeful that something from $30,000 10 years ago is now $700, I'm hoping that it will continue to go that way.
Mm-hmm. One other thing I remember, we were talking about the smell with leather, and we didn't talk about having some kind of extraction for smoke and you had mentioned about using a vacuum cleaner or a shop vac and buying some of that foam extraction. What's it called? A filter.
Yeah. So we buy a new shop vac, and then you buy a charcoal.
Charcoal.
Yeah, mm-hmm. Charcoal filter. And I think Amazon sells them, and a lot of places sell them. But you can get these pads here, the pads, cut to fit carbon pad for air purifiers, and we wrap that around a brand new shop vac. So buy like a $60 shop vac, wrap that around the inside of it, and then that becomes a pretty decent smoke scrubber.
Okay, so what I did was I went to Home Depot. And Home Depot has this, I think it may not be new, but it was new to me. They have this small little shop vac, and it's about the size of a toolbox. It looks like a toolbox. It's square, it's small. And what I found very interesting about it was a 5 horsepower motor in this small little shop vac. And it only has a capacity of about 2 gallons, but you're not collecting anything. So you don't need a big shop vac. The large shop vacs that you see, contractors using and all that, the real big ones, they're 6 horsepower.
Oh.
So this little tiny square toolbox is a 5 horsepower. It's, I think I all in with the filter and everything, I think it was $80.
Oh wow.
So, yeah. So that's what I did. I run that down by my cutter, down by my laser head. It works wonderful. I tried cutting one thing, and my shop filled up with smoke. I turned that thing on. I've never had any smoke in my shop since. Yeah,
no, it's a great idea. It's a neat little thing for $80. I'll have to get the what that one is so I can put it up on my website and tell people about it, because that sounds really neat.
Yep. So Home Depot sells them. They're a little square shop vac, and I think they sell a larger one, the larger toolbox square one again, but you only need the small one.
Great. Cool.
Okay, so any other questions? We'll wrap it up. Okay.
I thought I seen a package on there for doing printed circuit boards.
Yeah. Any of our lasers can. I would probably recommend getting the high resolution lenses, but we do circuit boards using kind of this paint method on copper, where it's a two-step process, but let's see, making prototype PCBs with J Tech laser. So they're going to go through the whole thing on how to do it here, on how to make your own PCBs. It's on the blog. We paint some copper, and then you take your Gerber file and you make it. We use our laser etch. You can use a lot of different programs to do it, but you make your file and you basically will take the paint off, and then that makes a mask. So then you can then use your acid bath to make it. Yeah. And the other cool thing we have for printed circuit boards is that we use to make our own prototype ones is cutting the solder stencils. So doing SMT work on circuit boards is very hard to do unless you have a solder stencil, and solder stencils are a little expensive. And this is kind of a neat way you can use Mylar transparency film, and we use that to make our solder stencils. So you take your SMT pads, and then you can go through, and I'm going kind of fast here because it's at the end, but you go through and you make your file, your G-code file, and then you take your piece of paper, your Mylar film, and you can go through, and it makes a pretty decent little solder stencil out of transparency film. So,
yeah, thank you very much for all the information. It was a great meeting.
Good. Yeah, you're welcome. Yeah, thank you everybody for showing up and listening to us.
All right, I just want to thank Jay for spending some time and letting us know all about his laser. It was great. I think everybody learned a lot. And I just want to remind others that are watching, if you want to see this, you can look on YouTube under Michigan CNC webinars and tips. Just search that and you'll find all the videos. Or you can contact me directly by sending me an email at tgauthier, so it's spelled TGAUTHIER @comcast.net. Okay, thanks a lot. Everybody have a great evening, and thanks for joining us tonight.
Great. Thank you guys.
Thanks,
Bye-bye.
Jay. You did a great job.